Acha. My screen is visible and I'm audible properly, Safia?
Yes, sir.
No. In chemical properties of alcohol, if I see the structure of alcohol, it is something like this. We have R, some alkyl group, CH2. This is considered a primary alcohol, and O. So basically, there are two different types of bond that can be broken and lead to the reaction of alcohol. Now, one bond is the carbon-oxygen bond, which can be broken. So we can have some reactions, including the cleavage or the breaking of CO bond. Right. So the CO bond can break. So we'll write breaking of CO bond. It can lead to some reactions. Breaking of CO bond. And the other one is the breaking of OH bond. Right. The breaking of OH bond, which can lead to some reactions. So we will study these type of reactions individually. We will first of all start with, please write the first part, that is breaking of OH bond. Breaking of OH bond. Write with me, the first reaction that we are going to see is the acidic nature of alcohol. In acidic nature, basically, we are going to first of all see the reaction with active metal. So you write number one, reaction with active metal. Just one. Guys, please, all of you, write this down quickly. Raise your hand once you're done. Then I will start the reaction. असलमान थोड़ा टाइम से ज्वाइन करने का कोशिश कीजिए, है ना?
यस सर, सॉरी खाना खा रहा था.
अच्छा. Okay, all of you done? Please see. A reaction with active metal. Active metals are those metals which, when reacted with acid, they give hydrogen gas. Fine. So, for example, you have sodium, magnesium, aluminium. All of the, if you remember the reactivity series of class 10th or class 12th also electrochemistry, if you have done, you may have heard about this word electrochemical series. So, any metal which is above hydrogen, which is more reactive than hydrogen, that is going to give you hydrogen gas when reacted with acid. So, for example, if you have ROH plus metal, this is an alcohol. Here, what it will do, it will give you MOR, metal alkoxide plus hydrogen gas. Now, depending on the metal's valency, we will get different types of alkoxide, or dialkoxide or trialkoxide. For example, if you have CH3OH plus sodium, since the valency of sodium is only 1, it requires only one alkoxide. So you'll have NaOCH3 plus H2. Similarly, if you have CH3OH plus magnesium, now the valency of magnesium is 2, so it will be MgOCH3 whole twice plus H2. The valency of aluminium, if I take, it is 3, CH3OH plus aluminium. This is going to give you aluminium methoxide whole thrice plus the hydrogen. I'm not balancing the reaction because balancing is not priority here. The priority here is the products. So we are getting hydrogen gas, that is a product. So we can say that, see, alcohols are generally weak acids. Okay, alcohols are weak acids. They react with metals to form hydrogen gas. Oh, if we have established that alcohols are weak acids, then we have to, of course, talk about the acidic strength of alcohols and the factors determining. Then also we'll compare the acidic strength with certain other compounds. Okay. So I hope you have written this down. Now you will write acidic strength of alcohol. That is an important topic. Acidic strength of alcohol. Now, if I look at the acidic strength of alcohol, then I have to see what is the conjugate base. So whenever we talk about the strength of acid, we have to see the conjugate base, because no matter what the acid is, it is going to give you H positive ions, right? It is, if it is going to break, it is going to break into R CH2O negative plus H positive. No matter how strong or weak acid is, we are always getting H positive. So if you're going to compare the H positive part of different, if you're going to compare the H positive part of the different acids, it will not make any sense. Rather, you have to compare the conjugate base, right? So when you remove hydrogen from any acid, whatever remains is known as conjugate base. Now, if we look at this particular conjugate base, this is your acid, you remove the hydrogen, you get what? You get the conjugate base. This conjugate base is what it is? Alkoxide ion. It's alkoxide ion. Now, in alkoxide ion, the conjugate base, we can say that acidic strength, this is in general, okay? The acidic strength, it is directly proportional to the stability of conjugate base. Because if our conjugate base is very stable, this can be on its own very freely. It can easily say to hydrogen, okay, fine, hydrogen, you can leave me, I'm already stable. The conjugate base is already stable, so it doesn't mind whether the hydrogen is with it or without it. So it can easily release the hydrogen and it is stable on its own. So acidic strength is basically directly proportional to what? It is directly proportional to stability of conjugate base. Now, if you look at any conjugate base, that conjugate base, it is going to have a negative charge. Also, one more thing that can be a deciding factor is the polarity between oxygen and hydrogen. We know that oxygen is more electronegative, so it will be pulling the electron towards itself. It will be getting a delta negative charge, and hydrogen will be getting a delta positive charge. Now, if this polarity is, just give me a second. Okay, so if you are going to increase the polarity, this oxygen will get a higher negative charge, this oxygen will get a higher positive charge. If the polarity is too much, then it will lead to a breaking point and it will be having H plus and O negative. So if the polarity of OH bond is very high, we are very near to H leaving the oxygen atom. So we can also say acidic strength is directly proportional to the polarity of OH bond. Now, this second factor is usually missed by many people. Okay, now, so you also have to keep in mind there are two factors which are determining the strength of the alcohol's acidity. The acidic strength of alcohol is determined by two factors: stability of conjugate base and the polarity of OH bond. Write this down. Raise your hand if you're done. Now we will look at both these factors while we are comparing different types of, while we are comparing alcohol and other compounds. Arsalan, just waiting for you, etc. So first of all, we will compare. Please write A part, alcohol versus water. So we are going to look at the dissociation part of water and alcohol. So if I have alcohol, we have already seen ROH. We will get RO negative plus H positive. And in water, that is HOH. We will be getting HO negative plus H positive. Right. Now let us compare the stability of conjugate base. The conjugate base is having a negative charge. And if I look at alcohol, the R group, this R group, it has a plus I effect. That means it gives electron density. It has an electron donating group. It is an electron donating group. So it will give electrons to the oxygen, which is already having negative charge, and the influx of the electron, the negatively charged electron, will increase the charge. When it increases the charge, this Ro negative will become, this will be much more, this will be less stable, काफी less stable. If I look at the OH negative, there is no plus I group and there is no increase in the charge. If there is no increase in the charge, we can say that it is more stable than the alkoxide ring. So first point that I can write, see, first factor, stability of conjugate base, mein who wins? Water is winning here. See, Ro negative is unstable due to plus I, rather I should write this, due to electron donating electron donating group. Like this, Ro negative is unstable due to plus I alkyl group. Since ठीक है. Now let us look at the polarity. ठीक है, let us look at the polarity. अब ध्यान से देखिएगा जरा. In the alcohol, now you have to look at the conjugate base, then you are going to look at the alcohol. In alcohol, the oxygen is electronegative element, right? I hope it is very clear. Electronegative element, it is going to pull electron density. It is going to pull the electron density. Now, there should be some capacity, it is some capacity of pulling the electron. There is some limit to it, right? Now, please imagine that we have already an alkyl group, which is donating group. So the alkyl group is already pushing the electron towards oxygen. When it is pushing the electron towards oxygen, it is fulfilling the needs of oxygen. एक आदमी बहुत भूखा है, and there are two groups attached to it. So the alkyl group is giving most of the electron density to oxygen and fulfilling its electronegativity demands. And that is why oxygen atom does not have to pull more electrons from hydrogen atom. So ज़्यादातर electron donation यानी pulling of electron is happening through the alkyl group. That is why the oxygen has to pull very little amount from the hydrogen, making this particular bond very less polar. So next point that I can write here is the ROH, that is rather I should write like this: OH bond in alcohol, OH bond in alcohol is less polar due to plus I alkyl group. Therefore, we can say what? Water, rather I should say write this, alcohol is less acidic than water. Alcohol is less acidic than water. अच्छा, अब यहाँ पे एक चीज बिल्कुल ध्यान रखिएगा. See, if anyone is asking you to write a reaction that shows the acidic nature of alcohol, you are only going to write this reaction. Because base के साथ ये react नहीं करता है, ठीक है? Please remember that. If they are asking, if they are going to NaOH वगैरह के साथ reaction मत कराइएगा. Don't react with NaOH. React with these active metals only. Because there is a question that has been asked, which write a reaction which shows the acidic nature. So acidic nature show करने के लिए they react with metals to form hydrogen gas. That is enough. Now, alcohol versus water we have seen. Right, next, 1 degree versus 2 degree versus 3 degree alcohol. Now, from this particular discussion that we have seen, we can say that the plus I group, it is destabilizing the alcohol. And it is not alcohol, it is destabilizing the conjugate base and making the alcohol less acidic. Now, in the B part, what we have to see, 1 degree versus 2 degree versus 3 degree alcohols. So from the previous discussion, we can completely write something that is acidic strength. That is acidic strength. It is inversely proportional to the plus I group that you are having. If you are having more plus I group, then the alcohol is even less acidic. So from here, we can easily justify that 1 degree alcohol will be the most acidic alcohol, the 2 degree, and then the 3 degree. Because 3 degree, it is going to have more plus I groups in alcohol. Make sense, yes or no? Please tell me. This is the order of acidic strength for 1 degree and 3 degree alcohol, right?
Yes, sir.
Acidic strength. Now, the C that we have to compare is alcohol versus phenol, right? C part, alcohol versus phenol. Now, again, if I look here, R CH2OH. This is a simple alcohol, and I have taken the most acidic primary alcohol. Okay? Now, moving on, it is going to dissociate into, just give me a second. Just give me a second. Yes, I need to plug in my. So when you have alcohol like this, RCH2OH, it is going to give you, we have seen that we have to have RCH2O negative. Now, it's same thing. The alkyl group, it is going to give electron density to the O negative, and it is going to make it unstable, right? So you'll write that unstable due to plus I group. Now, if I look at phenol and its dissociation of H positive, अच्छा यहाँ पे H positive भी होगा, ठीक है, I've not written it, but it is there. इसमें लिख लीजिए यहाँ पे. Now, if you look at phenol, so please see, the H will be gone, and you'll have O negative. इसको बोलते हैं phenoxide ion. Phenoxide ion, alkoxide ion. This is phenoxide ion. Now you can easily see that O negative can do resonance like this, and it can show resonating structures. So what I will write, this is stable due to resonance. Simple answers: unstable due to plus I group and stable due to resonance. Also, one more thing, we have already seen that this OH bond is less polar because of the alkyl group. Now, if you look at the benzene ring, so what is the benzene ring doing? If you see very properly, the benzene ring is taking electron density from oxygen. Now, if the benzene ring is going to take electron density from oxygen, oxygen will pull even more electrons from the hydrogen atom, making the OH bond very much polar. Making the OH bond very much polar. Also, one of the reasons why it is very polar, it is because this carbon atom to which oxygen is bonded, it is not sp3, rather it is sp2 carbon. And sp2 carbon atoms are more electronegative. So there will be a pull and push between oxygen and the sp2. Also, there is not only one sp2. If you look, all the benzene ring carbon atoms are all sp2, and that is why basically the benzene ring, it is an electron withdrawing group, not an electron donating group, making the OH bond in phenol more polar. If it is more polar, it is going to give out the hydrogen atom very easily. Now we can conclude that phenols are more acidic. I will write both the reasons, right? Phenols are more acidic than alcohol due to, number one, alkyl group in alkyl group in alcohol is plus I, making the conjugate base, if it conjugate base मत लिखिए, alkoxide ion लिखिए. The alkoxide ion less stable and the OH bond less polar. ठीक है, ये तो alkyl group की दिक्कत हो गई. Second reason why is the phenol is ज्यादा, the phenoxide ion is more stable due to resonance, and in phenol, the OH bond is more polar due to minus I effect of benzene ring. अगर सिंगल लाइन में अगर आपको आंसर लिखने के लिए आ जाए, बहुत टाइम आपके पास बिल्कुल मतलब टाइम नहीं है आपके पास, then the most important line in all of these is this line. It's more stable due to resonance. This is the most important factor. ठीक है? See, सारे factors equal नहीं होते ना. Not all factors are equal. They're important but not equal, right? They contribute little bit, but this particular line, the phenoxide ion is more stable due to resonance, is the most important factor in the acidic strength of phenol is higher than alcohol. Give reason question. Raise your hand once you're done. Krishna, you're done? Okay, fine. A very simple question. A and B both contains OH group. ठीक है? A turns blue litmus to red, but B doesn't. Identify A and B. इस तरह के आइडेंटिफिकेशन के सवाल आपके पास आ सकते हैं. नाउ अ वेरी इंपॉर्टेंट थिंग हियर इज डोंट गेट कंफ्यूज्ड कि हाउ कैन आई आइडेंटिफाई ए एंड बी इफ दे हैव नॉट गिवन यू द फॉर्मूला. यू डोंट हैव टू एक्चुअली डिटरमाइन द स्ट्रक्चर. अगर उन्होंने फॉर्मूला नहीं दिया हुआ है तो आपको स्ट्रक्चर नहीं बताना. यू हैव टू गिव द क्लास ऑफ द कंपाउंड. नाउ व्हाट आर द कंपाउंड्स दैट हैव द OH ग्रुप. सो यहाँ पे आप कार्बोक्सिलिक एसिड को मत लेके आइएगा. फाइन, बिकॉज द कार्बोक्सिलिक एसिड इट डजंट हैव OH ग्रुप. It has the COOH group, right? The C double bond O and the OH. This is the group that it has. ऐसा मतलब जैसे यहाँ तो OH है. It is not having the OH group. When we say carboxylic acid, when we have this particular compound, it is behaving as carboxylic acid and not as alcohol. So if somebody says that it has the OH group, it means either it is going to be alcohol or phenol, right? Now, as you can see in the question itself, they have given that A turns blue litmus red. Then obviously A is more acidic. A is more acidic than B, and the only available options are alcohol and phenol. So obviously, phenol is more acidic than alcohol. That is why I will say that A is phenol and B is alcohol. Write this down, guys. Done, everyone? ठीक है. अब देखिए एक important topic है ये. Now we are moving towards phenol in this particular case, but here only we are going to discuss the reaction or the some properties of phenols. बाद में एक बार और reactions of phenol में हम लोग discuss करेंगे. But acidic, since we have started the acidic strength, we should complete it here only. ठीक है. Now the acidic strength of substituted phenols. ये ध्यान दीजिए. This is also very important. Comparison पे यहाँ पे सवाल आ सकता है. Please write acidic strength of substituted phenol. Substituted means benzene ring, OH group, and there are some other groups also. Substituted phenol. Now, फर्स्ट ऑफ ऑल बहुत ही सिंपल सबसे पहली बात हम लोगों ने ये देख लिया दैट if we are having electron donating group, it is decreasing the stability of conjugate base and thereby decreasing the acidic strength. So we can say that all the electron donating groups, that is the plus M groups, these are going to decrease the acidic strength. These are going to decrease the acidic strength. What are these generally? आपके पास ये हो सकता है CH3 or it can be any alkyl group, CH3, or you can have any alkyl group. You can have OCH3 methoxy generally hota hai, or you can have any OR group, any alkoxy group, or you can have, let us suppose, one more OH group also, or NH2 group, all of these type of things. These are going to decrease the acidic strength. Right? When I have even one more OH, then this is also going to decrease the acidic strength. Now, these are what? These are the generally electron donating group which are going to decrease the acidic strength. Another thing is that we have electron withdrawing groups. These are minus M groups, which are going to increase the acidic strength. In minus M group, there are multiple groups, but most important that you are going to see is the NO2 group. Okay. Uske baad you can have C double bond O, wherever if you find C double bond O, like this. If C double bond O is present, whether it is aldehyde or ketone, then it is going to increase the acidic strength. Now, obviously, if you have carboxylic acid, the carboxylic acid part will show the acidic strength, so you don't have to worry about that. आपको ज़्यादातर in 99% of the cases you will get NO2 when you are comparing the phenols. Fine. Up next is what? Let us look at the phenol and where are the substitution that can take place. If I have phenol, there are 5 places which are left. 6 carbon atoms. One is taken. In one carbon we have the OH group, and remaining we have 5 carbon atoms. Now in 5, these are same. That is the ortho position. Then we have these are same. This is the meta position. Both of these, the blue ones, and then this one is what? It is the para position. Now, if you look at the ortho position, if there is something at ortho position, you have to check whether it is plus M or minus M. पहले, ठीक है? What you have to check? Check plus M or the group is minus M, and then you determine first, है ना? Check plus M minus M. Then, if it is not plus M, neither minus M, then you will check plus I or minus I. Or rather, what I say is that check both of them. पहले प्लस एम माइनस एम को चेक कीजिए, उसके बाद प्लस आई माइनस आई को चेक कीजिए, उसको लिख दीजिएगा. ठीक है? आई विल डू अ क्वेश्चन विद यू गाइस, देन यू विल अंडरस्टैंड हाउ टू अप्रोच दीस टाइप ऑफ प्रॉब्लम्स. नाउ इफ यू लुक एट दिस मेटा पोजीशन, इन दिस मेटा पोजीशन the plus m minus m does not work. In meta position it does not work, so you will here check only check plus I or it is minus I. And in the para position, again the same thing, you have to check plus m or minus m group, then you have to check plus I or it is minus I. ठीक है? Please write this down. बहुत ही सिंपल सा सवाल आया था एक बार, that is also there in your NCERT. It goes something like this. Basically, you have to give which is more acidic, that is O-nitrophenol versus I think it is O-methoxyphenol. And the also question is why, which is more acidic and why. So it basically depends on the structure. ठीक है? यहाँ ध्यान से देखिए. First of all, I will make O-nitrophenol, है ना? और the structure is also important कि आपको structure आना चाहिए. So you have OH here and nitro group that is on the ortho position, that is NO2. And O-methoxyphenol is benzene ring with OH group and OCH3 in the ortho position. Now tell me NO2 it is what? Plus M or minus M? I think it is there in your notebook now. Tell me guys, NO2 is what? अच्छा, ortho position में है, so what you will check whether the compound is plus M, whether the group is plus M or minus M. So NO2 is what? Plus M or minus M guys? No answers. You guys have not written or what? Safia, Mir, Arslan, Krishna Priya. NO2, it is plus M or minus M?
-m, sir.
Oh भाई क्या हो गया? Safia, Arslan and Mir. What happened? No idea?
No, -m.
Minus M, right? Acha, these words are not new, I hope, right? Plus M, minus M, ortho, para, meta. Are these new words for you? Yes, Safia, Arslan.
No,
No,
sir.
sir.
ना सो आंसर नहीं आ रहा है. ठीक है, सो यू हैव टू सी, यू डोंट राइट नाउ, ठीक है ना. अगर आपको समझने में दिक्कत हो रही है लिखने की वजह से, सो प्लीज ड्रॉप योर पेन, अंडरस्टैंड इट क्लियरली, एंड इफ आई एम मूविंग फॉरवर्ड्स एंड यू हैव नॉट रिटन, जस्ट टेल मी टू वेट. ठीक है, माय प्रायोरिटी इज नॉट द नोट्स यार, ठीक है ना, ये आपकी भी प्रायोरिटी नहीं होनी चाहिए. अगर नोट्स लिखने से आपको चीजें आ जाती तो द बेस्ट थिंग वुड बी व्हाट, to have the NCERT in front of you and write all the things whatever there is in NCERT, right? So see, I understand that sometimes I will be moving a little faster और आपके notes complete नहीं हो रहे, then just tell me to wait. ठीक है, I am never going to say that आप मतलब हाँ बहुत ज्यादा slow लिखेंगे, then I will tell you to speed it up and try to write faster, but in general prioritize understanding rather than writing the notes. ठीक है, fine. And that is why you can be in, I mean, in that case only you can answer my questions. If you are constantly writing, then it will be harder for you to understand also and write also. And mostly this is for guys. Okay, I have dealt with students, so what I see is that mostly girls, they can write and understand quite quickly. I mean, they can handle both the things at a time. But boys, I have seen that they can do one thing at a time generally. Arsalan, am I right? This is a huge,
Yes,
I
sir.
mean, what I can say, generalization, but this is something that I've seen. Obviously, maybe that Arsalan can read and write very perfectly, read, write, and understand very perfectly. But generally, I have seen that boys can do one thing at a time. So you try to understand first, Arsalan, and once you have understood, you will write even faster. Fine.
Yes, sir.
Okay. So NO2, you have said that it is minus M group. So if it is minus M group, it will stabilizes the phenoxide ion as NO2 is electron withdrawing group you like. And what about the methoxy group OCS3? It is plus M or minus M? Tell me guys. OCS3?
+m.
Plus M. Very good. So if it is plus M, then what it will do, it will destabilize the phenoxide ion as OCS3 is electron donating group. Fine. Now from this particular observation, what we can say, therefore, O nitrophenol is more acidic than O methoxyphenol. Got it? Take this one, please tell me.
Yes, sir.
Now, ये तो बहुत simple था. Let us compare a few different things, okay? You have a propanol and then you have a phenol, which is basically having NO2 in the ortho. Yep, we have written the structures at least. NO2 and NO2. Then we have, just copy this basically. Then you have NO2, suppose in the para position, meta position. And Need something else. बेसिकली इसको थोड़ा सा आसान करने के लिए क्या करेंगे हम लोग, ए बी सी डी नंबरिंग कर देते हैं, पी सी डी E and F. Right? Now, first of all, you will see that if all of these are same class of compound, then you will focus on plus M minus M plus I minus I. Now, what you see here is a different compound, that is alcohol, and then rest of them are what, phenol. So I can perfectly say that बहुत आसानी से, since alcohol is less acidic than phenol, so A will be the least acidic. Makes sense? Yes or no? Please tell me. Why? Only because this is alcohol. Right? So this is the first level, alcohol, and all of these are what? All of these are what? All of these are phenols. So you don't even have to see between alcohol and phenol. You know that alcohols are less acidic than phenol. ठीक है? अब next level पे आते हैं हम लोग. That is what between B, C, D, E, and F. Then what we have to see. ठीक है? ध्यान से देखिए सब, please. Now, in the B structure, if you see the benzene ring B, C, D, E, and F, the benzene ring and the OH is same in all of them. So you don't have to compare that. उसको देखने का कोई फायदा ही नहीं है. What you are going to see in B, C, D, E is what are the groups and where they are attached. Now in the B structure, you can see that NO2, this NO2 here, it is attached in which position? Ortho, meta, or para? Tell me, guys. बोलिए. Now you have to speak. Tell me. Ortho, meta, or para? NO2, it is in which position with respect to OH?
It is in all three positions. So.
नहीं, ये वाला, ये blue जो हमने highlight किया है.
Oh, that is ortho.
Ortho. What about this one?
Para.
Para.
Para. And this one?
That is also ortho, right?
Yeah, correct. That is again ortho, right? In ortho, you have to see whether NO2 is plus M or minus M. We have seen just now that it is minus M. In para also, it is going to be minus M. And in ortho again, it is going to be minus M. So what is the core effect of NO2 here? The core effect of NO2 is that it is 3 times minus M. Fine. Now we will move on to the C. Now in C, we have NO2 in which position? Tell me, guys.
Meta.
Meta position. Very good. So in meta, what we are going to see, whether we are going to see, tell me what we need to check if it is in meta position. Anji. Ari.
Minus plus M effect and plus I minus I effect.
Plus I minus I, right? So obviously NO2, it is more electronegative. Oxygen is also more electronegative. So it is going to be minus I effect. Here it is going to show what? Only one time minus I effect. And in the D case, you can see, now you can see very pattern wise, and बार बार आपको चीजें नहीं करनी पड़ेगी. Again, both of these are in meta position. So you can say that it is 2 times minus I. Make sense? Yes or no? Please tell me, guys.
Yes, sir.
Right? Now, next we have now the benzene and OH. यहाँ कुछ नहीं हो रहा. Right? So ये minus minus वाले दे दे, इसको 0 दे दीजिए. 0. ठीक है? एक क्वांटिटेटिव अप्रोच रखते हैं तो ज्यादा अच्छा रहेगा. माइनस है, माइनस आई, 0. And what about CH3? Tell me. CH3 का क्या इफेक्ट होगा? It is in para position, है ना? Para position, it will be what? Not it will be in para. Para position and CH3 it is going to be plus M, right? Now if it is plus M, I will write only one time plus M. Now, if you see here, alcohol is the least acidic. अब उसके बाद पॉजिटिव से नेगेटिव जाएंगे ना, बिकॉज माइनस वाले जो चीजें हैं दे आर इंक्रीजिंग द एसिडिक स्ट्रेंथ, तो प्लस वाला कम करेगा, राइट? अल्कोहल, उसके बाद प्लस वाला आएगा, दैट इज प्लस एम में एफ आ रहा है, प्लस के बाद आता है 0, So you'll have 0, that is E. After that, you have all of these minus. ठीक है? अब माइनस में माइनस आई पहले आता है, माइनस एम, मतलब माइनस एम का इफेक्ट बहुत ज्यादा होता है. सो लेस एसिडिक विल बी माइनस आई, मोर एसिडिक विल बी माइनस एम. तो माइनस आई में देखेगा तो एक माइनस आई आ रहा है सी में, सो नेक्स्ट विल बी सी. दो माइनस आई आ रहा है डी में, नेक्स्ट विल बी डी. एंड द मोस्ट एसिडिक विल बी बी, विच इज हैविंग 3 माइनस एम. सो ठीक है, दिस इज द ऑर्डर एंड दिस इज हाउ यू आर गोइंग टू अप्रोच. ठीक है, माइनस से स्टार्ट कर, मतलब जो आपके पास अल्कोहल को तो देख लिया, इट इज व्हाट, इट इज लेस देन फिनॉल. द रेस्ट ऑफ देम आर फिनॉल. तो आपने प्लस एम माइनस आई माइनस एम कंपेयर कर लिया. नाउ ऑब्वियसली आफ्टर अल्कोहल विल बी द प्लस वंस, प्लस से माइनस की तरफ जाना है. एंड ऑलवेज प्लीज रिमेंबर एक चीज, कि जो मेसोमेरिक इफेक्ट है, इट इज वेरी 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 स्ट्रॉन्गर देन द इंडक्टिव इफेक्ट. रेजोनेंस की वजह से वॉट एवर इफेक्ट यू आर गोइंग टू हैव, इट इज गोइंग टू बी मोर इफेक्टिव, ज्यादा इफेक्टिव होगा इसके इंडक्टिव इफेक्ट से. सो व्हेन यू आर हैविंग माइनस एम, इट इज गोइंग टू बी वेरी मोर एसिडिक rather when you are having minus I or 2 times also minus I. It doesn't even matter. So when you have inductive effect and mesomeric effect, no matter how high the inductive effect is, चाहे वहां पे 3 भी आ जाए inductive effect में, but still you are going to say that the minus M group, it is going to be more acidic, or it is going to pull more electron density from the phenoxide ion. ठीक है, please write this down, raise your hand once you're done. You understood now how to do these type of questions? Yes or no, please tell me.
Yes, sir.
Yes, sir.
Done all clear? Now, the next two reactions involving the cleavage of OH bond, these are very similar reactions. ठीक है? So, see here guys. When you react, let us suppose you have ROH. Don't write now, इसको समझने की कोशिश कीजिए. ROH, and you react this with carboxylic acid. ठीक है? I'm writing it like this: H O C double bond O and then R dash. Fine. So यहाँ से water निकलता है, और this is done in the presence of acid. Water gets removed and you get R O bonded with C double bond O and then R dash. So what we have got? We have got an ester. A very similar reaction, if you react this with, this is carboxylic acid, acid chloride के साथ react करा दीजिए, acid anhydride के साथ. Acid chloride is what? It is Cl bonded to C double bond O R dash. ठीक. Now एक सेकंड काम करते हैं, इसको यहाँ पे एक और रिएक्शन हो सकता है. So you write it here. You have Cl bonded to C double bond O and R dash. HCl will be leaving out from here and you will be getting R. Then you are going to have C double bond O. Sorry, just a second. HCl निकलेगा तो O बचेगा ना तुम्हारे पास. R O and then you will have C double bond O and then R dash. As you can see, we have again got what? We have again got ester. Next reaction है आपके पास, in which we use acid anhydride. So what is acid anhydride? देखिए, if you have acid, for example, C double bond O और OH रहता है ना, तो OH की जगह हाइड्रोजन रिमूव करके एक और एसिड का पार्ट ले आए, तो C डबल बॉन्ड O एंड CH3. Here you have CH3, C double bond O, O, CH, C double bond O, CH3. It is known as acid anhydride. Now, when you react this with acid anhydride, you are going to get again the same thing. क्या मिलेगा आपको? PC here. So यहाँ पे अगर आप देखें, so you will get R. This whole thing will be leaving. ठीक है? This whole thing will be leaving. So you will have RO from the alcohol bonded to C double bond O. और यहाँ पे CH3 है तो हम CH3 लिखते हैं. Now this is again an ester. Now this particular CH3 C double bond O oxygen will combine with the hydrogen and you will get one more thing, that is CH3 C double bond O and then OH. This is carboxylic acid. Now this is ester. This is carboxylic acid. So as you can see, all of these reactions are very similar. Basically, reaction ho kahan raha hai? The reaction is happening here. The hydrogen is combining with the OH of carboxylic acid. The hydrogen is combining with the Cl of acid chloride, and the hydrogen is combining with this particular group of acid anhydride, right? So all of these are very similar reaction. यहाँ पे भी OH bond का cleavage हो रहा है, right? The OH bond of alcohol is getting broken. Write these three down. Raise your hand once you're done. Then you will write some remarks. यहाँ पे एक और चीज देखिए, ईस्टर प्लस आपको क्या मिलेगा? यू विल गेट HCl. यहाँ पे आपके पास है ईस्टर, ठीक है, प्लस बेसिकली यू आर गोइंग टू गेट वाटर. Done all of you guys? Is anyone writing? No. Okay.
No, sir.
Write some remarks. First thing is that in reaction with carboxylic acid, the presence of bulky group on either alcohol or carboxylic acid decreases the rate of reaction. It decreases the rate of reaction. So for alcohol and for carboxylic acid, basically the rate of reaction will be fastest when it is CH3OH. एक काम करते हैं, दोनों का अलग लिख देते हैं. For alcohols पहले लिखते हैं हम. The rate of reaction will be fastest when you have CH3OH. That means the alcohol is not having any bulky group. This will be fastest, followed by 1 degree, followed by 2 degree, and then followed by 3 degree alcohol. Now for carboxylic acid, the fastest reaction will be if you have CH3COOH, rather I should say CH3, yeah, CH3COOH, followed by 1 degree, 2 degree, and 3 degree. Right, similar reaction is shown by phenols. Okay. Same reaction is shown by phenols also. Now, next point you will write, in a reaction with acid chloride and acid anhydride. Acid anhydride. We use pyridine as base, which reacts with the acid formed during reaction and shifts the equilibrium on product side. Okay, if you see these two reactions, when you're using acid chloride and acid anhydride, so you get an hydrochloric acid and carboxylic acid. So if you are going to decrease the amount of product, then you know that what happens according to Lee-Chatelet's principle in equilibrium, the alcohol, it is going to react more intensely with the reactants और ज्यादा प्रोडक्ट बनेगा. जितना ज्यादा प्रोडक्ट कम करते जाएंगे उतना ज्यादा प्रोडक्ट बनता जाएगा. ठीक है. So why do we use pyridine? If it is asked, then you will write this, that we use pyridine as base which reacts with the acid formed during the reaction and shift the equilibrium on product side. जो कुछ भी सवाल आया ना, pyridine के बारे में सवाल आएगा ऑर्गेनिक केमिस्ट्री में, pyridine का बस यही सवाल है. आप इस लाइन को लिखेंगे, इट इज यूज्ड एज अ बेस व्हिच रिएक्ट्स विद एसिड फॉर्म ड्यूरिंग द रिएक्शन एंड शिफ्ट्स द इक्विलिब्रियम ऑन द प्रोडक्ट साइड. ठीक है. चलिए, प्लीज राइट दीस पॉइंट्स डाउन. रेज योर हैंड. You guys are done? Here it is. Now here only write one point, that is preparation of aspirin. Now what is aspirin? It is carboxylic acid and OH. Now this OH group, now when it is reacted with CH3, C double bond O, OCH3, sorry, O, C double bond O and CH3. ठीक है, थोड़ा सा यहाँ पे ध्यान दीजिए. See, the O is attached with CH3 C double bond O, CO, sorry, CH3 C double bond O, CH3 C double bond O. ठीक है, तो इसको शॉर्ट फॉर्म में आपको कहीं कहीं इस तरह से दिखेगा, वोल्ट वाइज. ऐसे HOH को कैसे लिख सकते हैं? H2O. वैसे CH3 C double bond O दो बार अटैच हो रहा ऑक्सीजन के साथ, so we can write it like this: CH3 C double bond O and then volt wise O. ठीक है. Now when it reacts like this in the presence of an acid, then what's going to happen? You will have the COOH group as it is, the carboxylic group will be as it is. जहां पे आपके पास ऑक्सीजन था वो ऑक्सीजन वैसे ही रहेगा. And what this particular acid anhydride do, it introduces a C double bond O CH3 group. तो वही बस यहाँ पे CO C double bond O CH3 लग जाएगा. तो C double bond O and CH3 group is attached. Now if you write what is this? This is acetyl. इसको बोलते हैं salicylic acid. This is salicylic acid. And this is known as acetyl salicylic acid. Salicylic acid. Its common name is aspirin. Aspirin, the medicine. ठीक है. So this preparation is important. आपके टेक्स्ट बुक में डायरेक्टली दिया हुआ है, डायरेक्टली पूछा जा सकता है. Write the preparation of aspirin. Write this down. Raise your hand. I think you have already raised hand. So these are the only reactions in which we are having a cleavage of OH bond. You write the B part. reaction involving cleavage of the CO bond, or rather COH bond.
Sir,
No.
can you show the image for aspirin again?
Yeah, sure.
Yes, sir. 1 second, I just didn't write this last time part. Yeah, okay, sir, done.
Reaction involving COH bond. Now, majority of the reactions shown by this particular bond, because the polarity of carbon and oxygen bond, it is very highly polar, because carbon is electron donating and oxygen is electron withdrawing. And which oxygen जो होता है electronegative होता है, that's why it is going to pull electron density. That's why it is quite polar, and that is why it is easier to break. ठीक है, so please write the first point. और जितना ज्यादा पोलैरिटी होगा उतना आसानी से ब्रेक कर देंगे, तो उसी को लिख दीजिए हायर द पोलैरिटी ऑफ कार्बन ऑक्सीजन बॉन्ड, easier it is to break, easier it is to break the bond. और जितनी आसानी से ब्रेक हो जाएगा उतनी ही आसानी से reaction होगा, and the rate of reaction will be faster. Now, another point, as the number of alkyl group increases on alpha carbon. Alpha carbon मतलब the carbon that is having the hydroxy group, the OH group on alpha carbon. जितने ज्यादा आपके पास alpha carbon में alkyl group जुड़े हुए होंगे, the more intensely it will be giving electrons to oxygen. और जितना ज्यादा आप ऑक्सीजन को इलेक्ट्रॉन देंगे, the negative or the partial negative charge on oxygen atom will increase. And if it is going to increase very high, that means the bond will be very polar. So please write here, as the number of alkyl group increase on alpha carbon, the electron density around oxygen atom increases. Around oxygen atom increases due to plus I effect, making the CO bond more polar. ठीक है, मतलब क्या है इसका? For example, you have one carbon atom that is having OH group, and it is just bound to one carbon atom. So there is simple एक carbon atom इसको दे रहा है delta negative, थोड़ा सा charge increase किया. But if you have carbon atom which is having two carbon atoms attached to it, है ना? I mean, बाकी आप एक काम कीजिए, आप R लिख लीजिए जरा. R will be more easier to understand. And here you have CH2 भी लिख लीजिए, यहाँ पे आपके पास CHOH है. So this is 2 degree. In 2 degree, what is happening? There are two alkyl groups which are giving electron density. और उसकी वजह से the electron density around this oxygen atom will be very high. Delta negative charge will be very high. And then what is going to happen? If you have COH and there are 3 alkyl groups attached, then all of these 3 alkyl groups will be giving electron density towards the oxygen atom, making the partial negative charge even more high, making the carbon oxygen bond very much polar. Now, जितना ज्यादा polar उतनी आसानी से टूटेगा. That's why I can say, in general, rate of all the following reaction, whatever we are going to look, is that rate of the 3 degree will be highest, followed by 2 degree, then followed by 1 degree, and then at last will be the CH3OH. This will be the least, so the slowest one, है ना? Least fast, सबसे slow CH3OH reaction करेगा. So please write this down. आपके पास आएगा ना, like why the 3 degree alcohol is more reactive towards this reaction. आगे जितने भी reactions आने वाले, उसमें आप ये लिखें, as the number of alkyl group increases on alpha carbon, the electron density on oxygen atom increases due to the plus I effect, making the CO bond more polar. In general, अगर आपके पास सवाल आए that reactions involving the cleavage of COH bond, in that cases the 3 degree is more reactive. Why? उसके लिए ये आंसर है, in general आंसर है. बाकी specific answers for the different reactions वो भी आएंगे. Then there is writing this, yes or no, please, Sony?
Yes, sir, done.
Then there is no. The first reaction that we have to see is, please write with me, a reaction of, reaction with hydrogen halide. And this is a reaction that we have already seen in the haloalkane chapter, but एक चीज नया यहाँ पे introduce होने वाला है. What is the reaction? If you have alcohol, it will react with HX and it will give you RX, and substitution हो जाएगा. ROH will leave and it is going to give you RX plus H2O. It is going to give you plus H2O. Now, if I look at the reactivity of HX, तो HX में सबसे आसानी से रिएक्ट करने वाला है हाइड्रोजन आयोडाइड, followed by hydrogen bromide, followed by hydrogen chloride, and the least reactive is hydrogen fluoride. Now, if I am going to look at the reactivity of ROH, reactivity of alcohol, then in alcohol, we have to see that 3 degree will be most reactive, followed by 2 degree, followed by 1 degree, and then followed by methanol, that is CH3OH. Fine. And these are the general things that we have already seen. एक और चीज जो हम लोगों ने देखी थी is that Lucas reagent. Before writing about the Lucas reagent, you write a point that we did not discuss on the preparation of alcohol, but we have to discuss in the properties, preparation of haloalkane, but we have to discuss in the properties of alcohol. It is that due to lower reactivity, of 1 degree and 2 degree, 1 degree and 2 degree alcohol with HCl. और ये HCl के लिए ही खास है, because you can see that HCl is also one of the least reactive, और दो 1 degree 2 degree तो है ही कम reactive, right? Alcohol with HCl we use anhydrous ZnCl2 as catalyst. And due to this less reactivity, ये क्या करते हैं 1 degree 2 degree and 3 degree, they show the reaction at different rates, और उसी वजह से हम लोग क्या पता करते हैं, that which is 1 degree 2 degree and 3 degree, right? Now another thing, I think you remember this, right? Hopefully you guys remember this, is that HCl plus anhydrous ZnCl2, this whole combination, it is known as what? It is known as Lucas reagent. Known as Lucas reagent. Now, if we have Lucas reagent and you treat this with 1 degree alcohol, then what you are going to get? You are going to get turbidity. अच्छा एक पहले आप लोगों को शायद याद ना हो, maybe. See, any alcohol plus ROH, that is any alcohol plus Lucas reagent, it is going to give you RCl, that is having white PPT. Precipitate होगा प्लस पानी. तो वाटर में अगर आप चौक डाल दीजिए तो जिस तरह का, और उसको घोल दीजिए, so the kind of solution that you are getting, that is known as turbidity. Na? There is a white portion in the solution, but it is not part of the solution, rather it is a PPT. If you leave it for a while, it will settle down. Fine. तो उसी को turbidity बोलते हैं ना, whiteness जो होता है. Fine. Now what is going to happen when you have Lucas reagent and different degrees of alcohol? कुछ याद आ रहा है कि नहीं याद आ रहा भाई आप लोगों को? हाँ, अरसलान, सफिया एंड कृष्णप्रिया. हाँ जी.
Yes, sir.
Arsalan and Safia.
Yes, sir.
Yes, sir.
आ रहा है ना? So 1 degree में you will get turbidity on heating, room temperature पे नहीं मिलेगा. 2 degree में you will get turbidity after some time. Here you will get turbidity immediately. ना, तो यही है द डिफरेंस। सवाल अगर हम कर ले, अगर हाँ देखिए, तो थ्योरी हो गया, लेकिन सवाल में जवाब लिखने का जो तरीका होता है थोड़ा सा अलग होता है, ठीक है, ध्यान रखिए। फॉर एग्जाम्पल, इफ दे आस्क यू हाउ विल यू distinguish how will you distinguish between propane 1-ol and propane 2-ol, ठीक है। तो जवाब लिखने का तरीका ये होगा, आंसर में ऐसे लिखेंगे आप, we will use, लिखिए आपने use, we will use Lucas reagent। ब्रैकेट में डाला आपने HCl प्लस एनहाइड्रस ZnCl2, या फिर आप सिंपली एनहाइड्रस को ZnCl2 बस लिख दो, काफी होगा आपके लिए, ठीक है, ZnCl2। Now, then you will show that if you have propane 1-ol, 1, 2, 3, and then OH, the presence of HCl and ZnCl2, it is going to give you this Cl, that is white PPT, that, and you will write on heating, but not at room temperature. But if I have propane 2-ol, that is 3 carbon atoms and OH in the second carbon, and you react this with HCl in the presence of ZnCl2, is going to give you RCl. Is again the white PPT after 10 to 15 minutes. Check. Please copy this down. Raise your hand once you're done. Is anyone still writing?
Yes, sir. Yes, sir. Done.
No. No. Another important part of this particular reaction is the mechanism. In mechanism, first thing is that since we are having this is an SN2, well, not SN2, but rather it is nucleophilic substitution reaction. So you write that 1 degree alcohols react with HX via SN2. So when it is reacting by SN2, then there is not much scope. जिस कार्बन आटम पे OH लगा हुआ उसी पे आपको क्या मिल जाएगा, you will get the haloalkane. But let us see the mechanism, how it happens here, ठीक है। So you have, first of all, the first step is you have HX, it is going to dissociate into H plus and X negative, any halogen, right? X negative. Now in the second step, I am going to take a 1 degree alcohol, that is RCH2OH. Now the oxygen atom here, it is having lone pair. It will attack the H positive ion because it is having electron deficiency. It is going to attack like this, leading to formation of RCH2 as it is oxygen with 2 hydrogens and a positive charge because it is donated 1 electron. Now what will happen in the third step? The X negative will come forward, and please see, we'll have RCH2 oxygen, then there are 2 hydrogens like this. This is having a positive charge. Now, as you can see, oxygen, which is very electronegative, it will be pulling electron density from the carbon atom. And now it is having positive charge also, it will be pulling electron density more intensely. So this carbon atom will get a delta positive charge. Now, that's why this X negative, it is going to attack on the carbon atom. अब यहाँ पे एक सवाल आपके पास ये होना चाहिए, सर X नेगेटिव है तो ये ऑक्सीजन पे अटैक क्यों नहीं कर रहा है? So it is not attacking on oxygen because oxygen does not require electron. It is having what we call formal positive charge. यहाँ पे इसके पास इलेक्ट्रॉन्स के, एक तो होता है इलेक्ट्रॉन्स की कमी की वजह से you are having less electron, that is why you are having a positive charge. That is one case of positive charge. The other case of positive charge is when you are having only you are having in this case what is actually happening, this one electron it is shared with hydrogen atom. तो ऑक्सीजन के पास जो पॉजिटिव चार्ज आ रहा है, इट इज बिकॉज ऑफ शेयरिंग ऑफ इलेक्ट्रॉन, नॉट बिकॉज इट देयर इज अ डेफिशिएंसी ऑफ इलेक्ट्रॉन. ऑक्सीजन के पास स्टिल इफ यू सी, यहाँ पे दो लोन पेयर थे ना, एक लोन पेयर तो उसने अटैक कर दिया, एक लोन पेयर अभी बाकी है यहाँ पे. सो वन लोन पेयर इज स्टिल हियर. सो इफ यू काउंट द नंबर ऑफ इलेक्ट्रॉन्स, 1 bond, 2 bond and 3 bonds. 3 bonds means 6 electron, 7 electron, 8 electron. See, the octet is already complete. You cannot give electrons to oxygen atom. ये डाउट कभी बाद में आए ना कि सर ऑक्सीजन पे अटैक क्यों नहीं हो रहा, पॉजिटिव चार्ज है. तो प्लीज ट्राई टू अंडरस्टैंड द नंबर ऑफ इलेक्ट्रॉन्स ऑक्सीजन इज हैविंग. वहां पे अगर 8 इलेक्ट्रॉन्स है, it cannot have more than 8 electrons. That is why the attack will happen on the alpha carbon. As soon as this particular attack occurs, carbon cannot have more than 4 bonds. That is why it is going to give this particular bond electrons to the oxygen atom, and it will neutralize the oxygen atom also. So you will get R, the CH2 will be as it is, and you will get a halogen atom here. Plus you will get the water molecule. This is what happens when you are having a 1 degree alcohol. In the case of 2 degree alcohol, it goes via SN1. So you write here a point, 2 degree alcohols react with HX via nucleophilic substitution unimolecular. ठीक है, which occurs by the formation of carbocation. अब यहीं पे एक सवाल है एनसीईआरटी में, which can be labeled as haloalkene का सवाल या अल्कोहल, दोनों का ही सवाल, because the reactant is alcohol and the product is haloalkene. So you have something like this. You have CH3, CH bonded to CH, then bonded to CH3, and this here CH is having a CH3. और इस कार्बन एटम के पास है OH. Now when you are going to react this with HBr, तो आपको क्या लगेगा? This whole thing will be as it is, except OH की जगह क्या आ जाए? OH की जगह Br आ जाए. This is the expected product. But what actually you get is not the product that we get actually. The product that we get is rather CH3 bonded to carbon atom, which is having a CH2 followed by a CH3. This carbon atom is having one CH3 group more, and there is a Br atom on this particular carbon atom. This is the actual product that we get. Now how but this product is getting formed, इसी को देखना है. ठीक है, ध्यान से देखिए. Now what you need to do is you need to leave the pen aside. ठीक है, please leave the pen aside and just try to listen. Just give me a second. Now here I will make this compound like this. We have how many carbons? We have 4 carbon atoms. So I will draw 1, 2, 3, 4. The second carbon atom, it is having a CH3 group. The third carbon atom is having a OH group. Now the first step will be still the same. That is the HBr will break into H plus and Br negative. There will be H positive ions roaming around. So the oxygen's lone pair electron, it is going to attack on the H plus. I should make it with a small type of arrow. It's going to attack on the H plus like this. And we are going to get a similar case as we got in the 1 degree. CH3 is as it is. There's no change here. All the carbon atoms are as it is. This oxygen atom, it is getting just 1 electron, sorry, 1 hydrogen and a positive charge. Now, as soon as this particular gets a positive charge, what will happen? This particular bond, it is going to break and it is going to go away. And this will lead to the formation of carbocation. Now, again, this is almost in equilibrium. Equilibrium की जगह क्या बोलना ज़्यादा अच्छा है? It is reversible reaction. So you'll have 1, 2, 3, 4 as it is. Then you have CH3 here. And here you get a positive charge. You get a positive charge. Now something very wild happens. ठीक है, यहीं पे आपके पास जो चीज है, here what happens, it is very important. ध्यान से देखिए guys. If you look at this particular carbon atom here, this carbon atom will have one hydrogen atom. Now this hydrogen atom, it is having electrons और यहीं पे positive charge है. So just for a fraction of second, guys, I'm saying what? For a fraction of second, what can happen? The electrons of the CH bond can be pulled towards the positive charge, और ये हाइड्रोजन के साथ अपने इलेक्ट्रॉन के साथ यहाँ पे आ सकता है. Just for a second, ठीक है? What I am saying, it is very important, is that just for a second, for a small time, we can have this molecule. 1, 2, 3, 4. The CH3 is as it is. And now, since the hydrogen is going with the electrons, the positive charge will be on this carbon atom. Now, as soon as this particular carbocation has been formed, अब बात आएगी stability की थोड़ी. If you look at this particular carbon atom, here it is attached with 2 carbons only, making it 2-degree carbocation. This carbon atom, it is having 3 carbon groups attached to it, making it 3-degree carbon. This is more stable. अब जो ये एक बार बन गया for a second, it will not go back to the 2 degree, because 3 degree is more stable. It will stay in 3 degree. Make sense? Yes or no? Please tell me, guys. This is the most important part. यही चीज जो है आप लोगों को समझनी है. When you have carbocation, it can rearrange itself. You understand this point? For a second, because positive charge is present and positive attracts negative, so positive will attract the electron of CH bond, and the hydrogen will shift towards the carbon atom having positive charge, leading to a positive charge on the 3-degree carbon. And since 3-degree carbocation is more stable, it will not go back. Make sense? Yes or no? Please tell me, guys. Safia, Arslan, and Krishna Priya.
Yes, sir.
So
Yes,
this is
sir.
known as hydride shift. This is known as hydride shift. अब इसके बाद here comes your X negative. X negative नहीं, Br negative ले लेते, because we had Br. We have Br negative. Now this Br negative, it can easily attack on the positive charged carbon atom here, the carbocation, and which will lead to the formation of CH3 Br. So if you expand the structure, it will be CH3 bonded to carbon, which is having a CH3 here, then CH2 CH3 with Br, which is our actual product. Okay, so you'll write a point. Since 2-degree alcohols, 2-degree alcohol reacts with HX via SN1, reacts with HX via SN1, they can give a rearranged product. There are two more classes of, there are 2 more reactions in this particular class of breaking of COH bond. ठीक है. Second, ये पहला एक reaction था जिसका डिटेल हम लोग को पढ़ना था. Then we have reaction with phosphorus halides. Then we have reaction with thionyl chloride. Now, both of these reactions are already done in method of preparation of haloalkane. Okay, so you leave almost like half page, half means leave one page क्या बोलेगा, leave 70% of the page and वहां से आप copy कीजिएगा. There is not much in these reactions with phosphorus halide and thionyl chloride. सारे के सारे में आप you will get haloalkane as the product. Then guys, this one please me. Is anyone still writing?
Sir, I'm done.
Then what about others? Safia, Arslan, Safia, Mir, and Krishna Priya.
Done, sir.
Done. ठीक है. These two reactions के लिए आप प्लीज थोड़ा जगह छोड़ दीजिए और उसके बाद इंपॉर्टेंट रिएक्शन एक है दैट इज एसिडिक डिहाइड्रेशन. Now, acidic dehydration, it is very similar to the beta elimination we did in haloalkanes. You need to have carbon with one carbon having hydrogen, the other carbon should have OH. बाकी जो कुछ लगा रहे, it should be as it is. There should be no change there. What is going to happen if you add H plus in the presence of a bit of heat, then you will be having carbon, double bond carbon. The two groups which are attached, they will be as it is, and you will get water as the byproduct. So dehydration, why? Because we are removing hydrogen from the. Acha, isko dekh lijiye. This is alpha carbon, the carbon having COH bond, and this is the beta carbon. So this is also beta elimination. Right? What is happening? We are removing OH from the alpha carbon, and we are removing hydrogen from the beta carbon, and then making a double bond between alpha and beta. So तीन step हैं यहाँ पे जो आपको याद रखना. First is what? Remove OH from alpha. Second is remove hydrogen from beta. Third is, and everything else will be as it is. अब ये चीज, यही changes, these are the only changes that you have to do. Everything else will remain as it is. You have to only focus on the alpha and the beta carbon. That's it. And then you have to make alpha double bond beta. अरे भाई, और alpha double bond beta मत कर दीजिएगा, alpha carbon double bond beta carbon. ठीक है? That's the only thing that you have to do. सबसे पहले तो आप प्रोडक्ट बनाने यहाँ पे सीखिए, बाकी इसके मैकेनिज्म वगैरह बाद में आए. ठीक है? Now this also occurs via Setzeff rule. ठीक है? Right here, this reaction occurs via Setzeff rule. That is, more substituted alkene is the major product. ठीक है? But now again, this Setzeff rule I'm just writing because if they ask, the dehydration of alcohol occurs via dash. So you have to say that it occurs via Setzeff rule. है ना? अच्छा, this is also known as AKA beta elimination. Fine, this is also known as beta elimination. अब ध्यान दीजिए जरा, प्रोडक्ट बनाने का तरीका, it is going to be similar to what we did in the dehydrohalogenation case. क्या किया था हम लोगों ने? For example, let's see first question. You have 1, 2, 3, 4 carbon atoms, and then you have OH. यहाँ पे आपके पास alpha carbon है, and then here you have beta 1 and beta 2. Beta 1, this is the beta 1 carbon, this is the beta 2 carbon. So beta 1 की डिग्री लिखिए आप, this is 1 degree, beta 2 की डिग्री लिखिए, this is 2 degree. So आपको दो प्रोडक्ट मिलेंगे in the presence of H plus and a bit of heat. You will get 1, 2, 3, 4 as it is. You will remove the OH from alpha and hydrogen from beta. उसके बाद double bond between alpha and beta. एक आपको ये मिलेगा plus 1, 2, 3, 4, and you will get this product. Obviously, which one will be major? Tell me, guys. कुछ याद है तो? First या second? कौन सा major होगा? Which will be major product? More substituted वाला बताइए. If you remember, 1 degree के साथ double bond या 2 degree के साथ double bond? Which will be major, guys? Beta elimination. 2 degree वाला major है ना? Very good. So this will be major and this will be minor. Now, in the following reactions, we will be only focusing at the major product, है ना? बाकी हम लोग को माइनर से उतना लेना देना नहीं है. ठीक है? सेकंड में चलिए, अब आप प्लीज स्टार्ट हो जाइए जरा. प्रोसेस पे प्लीज आप लोग ध्यान रखेंगे, यू विल ओनली फोकस एट द प्रोसेस, यू आर नॉट गोइंग टू लुक वेदर द प्रोडक्ट इज लुकिंग अगली या आपको ठीक नहीं लग रहा है। डरिएगा मत कहीं भी बॉन्ड बनाने से, यू बस ये ध्यान रखिए द बॉन्ड शुड बी बिटवीन अल्फा एंड बीटा कार्बन ओनली, इधर उधर नहीं बनाएंगे बॉन्ड आप। Write the products of following. I'm going to extend the class a little bit today. Okay. I couldn't take yesterday's class because of some reason. The important thing is that you identify alpha, identify beta carbons, 1 डिग्री 2 डिग्री लिखिए, फिर उसके बाद मेजर माइनर, अगर आपको लग रहा है मेजर माइनर लिख के आपको ज्यादा कंफर्टेबल होगा, यू राइट बोथ मेजर एंड माइनर प्रोडक्ट्स एंड देन गिव व्हाट इज मेजर एंड व्हाट इज माइनर, ठीक है। इफ यू आर गिविंग मी ओनली मेजर दैट इज आल्सो फाइन, बट डू व्हाट यू आर मोर कंफर्टेबल विद, है ना, जिसमें आपको ज्यादा सही लग रहा है, डोंट बी लेजी बट, ठीक है। I need to see the alpha carbon, I need to see the beta 1, the beta 2, the 1 degree, the 2 degree and all of these things, है ना। जितना आप अच्छे से if you are going to work on the problem, तभी आपके पास प्रोडक्ट सही से बना पाएंगे। if you are not going to work, आप दिमाग में चीजों को करेंगे जितना ज्यादा, उतनी गलतियां की चांसेस ज्यादा हो। so if you are going to write it down, आपको लिखते ही समझ में आएगा, अच्छा ठीक है हम गलत लिखते हैं। 3 डिग्री को 2 डिग्री से मिस्टेक करना दिमाग में ज्यादा आसान है, बट यू विल, it's very hard to do a mistake if you're writing in the copy and you're doing okay 1 कार्बन 2 कार्बन 3 कार्बन से जुड़ा हुआ तब 3 डिग्री है, ठीक है। so please focus there, work on the problems, है ना, don't think on the problems, work on them. Guys, take 3 more minutes. गाइस अगर डाउट आ रहा है तो प्लीज लेट मी नो. अच्छा, ऑल्सो वन मोर थिंग, इफ यू आर डन विद द सेकंड वन ना तो उसको प्लीज भेज दीजिए जरा. प्लीज सेंड मी इफ यू आर ओनली डन विद द सेकंड वन ऑल्सो. अगर आपने सेकंड थर्ड फोर्थ किसी में से कुछ भी कर लिया प्लीज उसको भेज दीजिए. Important one answer from Arsalan. Yes, alpha, beta 1, beta 2. Very good. This makes sense, right, Arsalan? Not having problem, है ना? आसानी से हो
Yes,
गया.
sir.
ठीक है, ऐसे बिल्कुल हर चीज लिख लिख के कीजिए, आसानी से हो जाएंगी. कृष्ण प्रिया. Now, Krishna Priya, the last answer there is a mistake. Can you identify the mistake, Krishna Priya?
The last one, sir.
Yep, the last one. I understand it was a tricky question, but still identify the mistake. Try to identify the mistake. It is something related to the 10th standard. The first time you were introduced with carbon, what was the first thing that was told to you about carbon atom? Tell me, Krishna Priya.
Tetravalent.
Yep. Now try to see that.
Oh, yeah, the valency. It doesn't match.
So also one more thing that you can see, the beta carbon in which you have made the double bond, it does not have any hydrogen in it, right?
Yes, sir.
तो वहां से हाइड्रोजन रिमूव हो ही नहीं सकता है. सो दैट इज नॉट अवर पोटेंशियल बीटा. अब हमने एक सवाल करा दिया है. आई मीन इसमें बहुत सारे सवाल बन सकते हैं इस तरह के, बट यू जस्ट हैव टू कीप एन आई फॉर दिस टाइप ऑफ क्वेश्चंस, है ना, वेयर यू डोंट हैव अ हाइड्रोजन ऑन द बीटा कार्बन. ठीक है, चलिए. सी सफिया, आपका यही पे आंसर नहीं आया. सफिया, आर हैविंग डिफिकल्टी इन दिस टाइप ऑफ क्वेश्चन?
Yes, sir.
ठीक है, सबसे पहले आप अल्फा कार्बन देखिए ना. अल्फा कार्बन, ये कार्बन अल्फा हो जाएगा, ये सुनो. कितना कर पाएंगे?
Yes.
पक्का. थर्ड और फोर्थ में जल्दी से अल्फा लिखिए, कौन कौन सा कार्बन है. डन.
Done, sir.
अल्फा के बगल वाला, अल्फा के बगल ये कार्बन भी है और अल्फा के बगल ये कार्बन भी है. मेक सेंस?
Yes.
सो आप इसको नाम दे देंगे, दिस इज बीटा 1 एंड दिस इज बीटा 2. फाइन. ओके सत्या.
Yes, sir.
नाउ बीटा 2 इसकी डिग्री क्या है? व्हाट इज द डिग्री ऑफ बीटा 2?
1 degree.
1 डिग्री. एंड बीटा 1 इज
3 degree.
3 डिग्री. सो आप दो प्रोडक्ट बना लीजिए. आपको क्या करना है? मेक द कंपाउंड एज इट इज except the OH. Make the compound as it is except the OH एंड मेक अ बॉन्ड बिटवीन अल्फा एंड बीटा। किसके बीच में बनाना चाह रहे हैं, बीटा 1 या बीटा 2? टेल मी।
बीटा 1।
बीटा 1 के बीच में बना दिया आपने। और दूसरा प्रोडक्ट, मेक द कंपाउंड एज इट इज एक्सेप्ट द OH। और अब एक बीटा 2 बचा, बीटा 2 बचा। नाउ द हायर द डिग्री दैट विल बी मेजर। 3 डिग्री के साथ वाला मेजर, और 2 डिग्री 1 डिग्री के बाद वाला माइनर। गॉट इट?
यस सर।
जल्दी से थर्ड वाला कीजिए, सेकंड मत कीजिएगा, है ना। थर्ड वाला कीजिए, अल्फा बीटा 1 बीटा 2 सब कुछ कीजिए, एंड देन सेंड मी द आंसर क्विकली। Sophia, send the answer quickly.
यस सर।
बस वो प्लीज कीजिएगा, है ना, अल्फा बीटा 1 बीटा 2 एंड द डिग्रीज, तभी जाके आसानी से होगा।
ओके।
थर्ड वाला ना, थर्ड वाला, फोर्थ कर दिया आपने।
ओके सर।
फोर्थ थोड़ा सा टिपिकल, थर्ड वाला करना है, थर्ड वाला। प्रोसेस इज फाइन, नो प्रॉब्लम इन दैट। थोड़ा सा बस उसमें ट्वीक कर देंगे तो पता हो जाएगा, समझ में आ जाएगा आपको। फोर्थ वन इज अ बिट ट्रिकी। थर्ड वाला जल्दी भेजिए। मेजर माइनर देखिए जरा।
सॉरी सर।
मेजर माइनर देखिए, सही है।
ओ नहीं सॉरी सर।
ध्यान से, है ना, इसी वजह से हम कह रहे थे 1 डिग्री 3 डिग्री ये सारी चीजें भी लिख दिया कीजिए। ठीक है, दिस इज अल्फा, दिस इज बीटा 1 मान लेते हैं, इसको बीटा 2 मान लेते हैं। बीटा 1 इज 3 डिग्री, बीटा 2 इज 2 डिग्री। सो दो प्रोडक्ट बना लेते हैं, एवरीथिंग एज इट इज एक्सेप्ट दी OH CH3, alpha and beta 1 double bond plus everything as it is except the OH CH3 double bond between alpha and beta 2, this will be major. अब थोड़ा सा यहाँ ध्यान देते हैं, जो कि आप लोगों ने, सारे लोगों ने किया होगा। तो दिस फोर्थ क्वेश्चन इज व्हाट, आपने कुछ इस तरह से किया होगा ना। देखिए, सी हियर दिस इज alpha, this is beta, and this is beta. Beta 1, beta 2. This is what, 2 degree, and this is what, 4 carbon atoms to 4 degree. So you must have gone in this way. Everything as it is, except the OH, the CH3s are as it is. Alpha or beta 1 between double bond. And then you must have made something like this. CH3s as it is, alpha or beta 2 between double bond. Now the problem with the next product that you are making is 2. सबसे पहले तो देखिए यहाँ पे, this carbon atom, the beta 2 carbon, it is not having any hydrogen because all the tetravalency होती 4 groups that it is having, it is CH3. 4 bond already है इसके पास, so it does not have any hydrogen. If the beta is not having any hydrogen, what is the use of beta? Beta से hydrogen निकालना रहता है, right? So there should be at least one beta hydrogen. तो वो beta hydrogen यहाँ पे है नहीं मौजूद. So obviously that beta is not going to take part in the reaction. And once you have made the product, then you have to realize, आपने मान लीजिए यहाँ पे उतना नहीं ध्यान दिया, जब आपने यहाँ product बना लिया तब यहाँ पे देखिए आप, it is having 1 bond, 2 bond, 3 bond, 4 bond and 5 bonds. Now carbon atom की tetravalence होती है, it can form only 4 bonds. So this product is not going to happen also. मतलब ये होगा ही नहीं, because there is no hydrogen in the beta 2, then it is not going to take part in this particular type of reaction. ठीक है? So this will be the only product. ये product रहेगा नहीं. तो if you have only one product, तो वहाँ major और minor नहीं लिखा जाता. फोर्थ वाला सेंस समझ में आ रहा है सबको? ये सुनो प्लीज, सुनिए, अरसलान, मीर, सफियान, कृष्णप्रिया.
Yes, sir.
Yes, sir.
You'll write a point here. 4 degree carbon, 4 degree beta carbon कर देते ना, 4 degree beta carbon is not considered in dehydration of alcohol in this reaction, as it does not have any hydrogen atom. Done, all of you? After this, you can write mechanism. So in mechanism, you have to see R CH3, CH2, OH. In the presence of H plus and a bit of heat, it is going to give you CH2 double bond CH2 plus water. So what are the different steps that we are having? Now, since this is occurring in the presence of an acid, basically we take H2SO4 in this cases. Step 1, it is, these mechanisms are important, okay? Step 1 is protonation of alcohol. Protonation of alcohol. So we have CH3, CH2, OH with lone pair electrons. From the acid, we will get H plus, and this is going to attack here, leading to formation of CH3, CH2, and then we have oxygen, and then 2 hydrogens like this with a positive charge. Now, the second step, step 2, is formation of carbocation. Formation of carbocation. The formation of carbocation, we have CH3, CH2, oxygen with 2 hydrogens like this, the positive charge, and this bond breaks, leading to formation of CH3 bonded to CH2 positive plus H2O. After that, we have deprotonation of alcohol, step 3. देखिए, जहां से आपके पास H+ आ रहा है, वहीं आपके पास कुछ नेगेटिव चार्ज anion भी होगा. Now that negative charge anion actually takes the H plus. But simply आपको बस ये याद रखना है, around the beta hydrogen आप इस 3 hydrogen को दिखाइए around the beta carbon. Then you have CH2 positive. Basically, this hydrogen will give the electron density here, leading to formation of CH2, double bond CH2, and H plus like this. H plus is used as a catalyst, और आपको यहाँ पे क्या मिल चुका है? You have got alkene. Write these 3 steps. Raise your hand once you're ready. Waiting for Krishna Priya and Meer. After this, you'll write a few remarks. Write the first point. Dehydration of alcohol occurs via formation of carbocation. Formation of carbocation. Therefore, rate of dehydration it is what 3 degree fastest, followed by 2 degree, and then followed by 1 degree. Then you will write next point as 2 degree and 3 degree alcohols are reactive. They can form alkene at lower temperatures and milder acid. So for example, if you have 2 degree alcohol, then you need not even H2SO4, you just need 85% of H3PO4 and a temperature of 440 Kelvin. You'll get an alkene like this. When you have 3 degree, for example, something like this, 3 degree alcohol, then you just need a 20% H3PO4, and the temperature that you need is 358 Kelvin. And there you will get something like this. Okay. Anyone still writing?
No, sir.
Okay. So that's it for today, guys. And there are a few more reactions remaining for alcohols, and there are around 5 reactions for phenols. Okay. Apart from the electrophilic aromatic substitution reactions that we are going to see in the next class. Do you guys have any holiday this week? Yes, guys.
No, sir.
No, sir, for me, Thursday is the last day of my school.
अच्छा, you're having vacations. आप लोगों का vacation कब है? Safiya and Krishna Priya?
Mine starts next week, sir, on the 22nd.
22nd. What about you, Safia?
Same, sir. 22nd.
22nd. ठीक है. Fine. Then see, in mornings I will be taking classes from 22nd daily. ठीक है. From
ठीक है
22nd, it's Friday. We will start from 23rd, 24th. I will be taking classes daily. ठीक है. तो हम टाइम अभी फिक्स कर रहे हैं ताकि आप लोग के और भी क्लासेस है ना, वो उनके भी. एनीवन, आप लोग और भी क्लासेस कर रहे हैं यहाँ पे? फिजिक्स, मैथ्स, बायो.
नो सर.
व्हाट अबाउट अदर्स? असलान, सफिया.
Yes, sir.
सफिया फिजिक्स.
No, sir. Nothing.